Welcome to the Thailand International Mathematics Olympic Mock Examination 2021 to 2022. Now, this lecture is for the secondary 2 student. In this lecture, we will discuss the paper of which it contains 30 questions divided into 5 separate different sections. Logical thinking, arithmetic, number theory, geometry, and combinatorics. Now, the time allowance for this mock examination is 19 minutes. This is the same as the real examination. So, in other words, you have 19 minutes to finish 30 questions. So that means that you have only 3 minutes to finish one question. That's why if you do not know how to solve the question at first glance, I would recommend you to skip this question and to go on for the next one. You should always try to finish all low-hanging fruit first before you tackling some difficult question. I know that some of you may be accustomed to finish a paper from the first to last and to finish it in that order. But please do not do this for this examination, as time is of its essence. You don't have time to waste, okay? So just like this lecture, we don't have time to waste, and without further ado, action. Okay, question number 1. Now, the June of 18th of 2021 is Friday. What would be the day of the week of June of 18? Now, this is the same date of the year. This is the same date of the year. The only thing changes is the year. Okay, it will go from our 2021 to 2029. So here comes my question. How many days has passed from 2021 to 2029? Now we can count it by hand. Now here we go from 2021, and then later on, we go to 2022. And then 2023, 24, 25, 26, 27, 28, and finally 29. Okay. Now, how many days are there for each year? How many days have passed for you to go from the June of 18 of 2001 to June of 18 of 2002? Now notice the day that have passed is the same as the number of days for that year. So for you to go from 2021 to 2022, there are exactly 365 days that passed. Because this is exactly the number of days of the year 2021. Now the same thing goes for 2022 to 365. The same thing goes for 2033 to 2034. But from 2024 to 2025, there are actually 366 days have passed. Why? Because 2024 is a leap year. Now, after which we'll go back to a normal year. And then because our 2028 is also a leap year, so we have another 366 days have passed. Now, so by this, we can compute the difference between the number of days between the June of 18 of 2001 to June of 18, 2029. Now this is possible, and by knowing the difference of dates, we divide it by 7. So we separate them from the number of complete weeks and to come to the number of remainder day, the date remain, and by the date remain, we can calculate this date of the week. Okay, because passing every week does not affect the date of the week. Okay, so now of course we can sum up the difference of date. The day passed by can be computed by adding all this date or this number of dates together. Of course, this can be done. This can be done. Now, this is not efficient, but it can be. So what's the value of it? So it will be equal to 3068 times 6 plus 3066 times 2. If the answer will be equal to 2922. Now by this we can divide this number. This is 2,922 days. So we can divide it by 7. We can find out that this is equals to 417 weeks. Now the number of weeks is not important, plus our free days. This is not important because any complete week will not affect the days of the week. But the number of days here is important because the number of days will change it from Friday to our Saturday to our Sunday, and finally to our target, which is our Monday. So Monday is our answer. Monday is our answer. Now, this is just one way of doing this. Another way to do this is to divide by 7 as early as when we calculate the years. So in here for 365, it is equivalent to be adding 1 to the day of the week, because if we divide 365 by 7, we will get a remainder of 1. So this is also divided by 1. And this is also divided by 1. Before a leap year, it will be equivalent to be adding 2. So be adding 1, adding 1, adding 1, adding 2. So this will be equivalent to adding 10. But adding 10 is just equivalent to our 3 days here. So no matter which method we are using, we are still thinking that it will be equivalent to 3 days after Friday. Okay, so this is the solution of question number 1. Now let's go to question number 2. Now question number 2 is a question of worst case scenario. Now, whenever we see a question ask you at least something is happened, you will know that this is asking you about our principle of least favorable. Sometimes which we call the worst case scenario. Now, what is this mean? What does that mean? It means that instead of looking into the things that we want, if we look into things which is opposite to the things that we want. So let's go through this question, shall we? Now, in here, what do we want? We want to get 2 pairs of orange chopstick and 2 pairs of green chopstick. So what's the opposition of this statement? Because 2 pairs of chopstick means there are 4 of them, right? So if we want it to be not true, so it means that there are no 4 or more chopstick, no orange, and now because it is a 4 or more orange chopstick and 4 or more green chopstick. So in here, now at least one of them fails and the whole thing will fail. So instead of and, it will be equals to or. So the second condition is that it is of no 4 or more, which is of green. Now notice how the statement in orange is a direct opposition of the statement in green. No 2, because we have no 2 pairs of orange chopstick and no 2, we have 2 pairs of orange chopstick and 2 pairs of green chopstick. The direct opposite of it is that either you did not satisfy the first condition, so it means that there's no 2 fourth chopstick, or you does not satisfy the second condition. That means that you have no 4, which is green. But by this, we can calculate the minimum value of each of this. So in order for it to be no, in order for it to be having no chopstick, which is of or no 4 or more orange chopstick, it will have to be, so the number of red chopstick you can have is all of them, right? There's no requirement, but for all chopstick you can have at most 3, and for green chopstick you can have all of them. Okay, so in total, for our first condition, it will have at most 10 plus 3 plus 18. Or in other words, it will be equals to 31. Now for our second condition, no 2 or more green, so it means that there must be at most. Now again, for our red chopstick, you can take any of them. For our orange chopstick, you can take any of them. But for our green chopstick, you can take at most 3 of them. So they both combine to 38. Because any one of this failed, the whole thing will fail. So it means that this must hold true for any one of them. So it must be either at most 31 or at most 38. So of course, the situation in here must be at most 38. This is the largest number in here. But notice that this is the direct opposite for our statement. So our conclusion must be the direct opposition of our answer. So for our answer, it must be at least 39 chopsticks. Okay, so this is question number 2. This is question number 2. And our answer will be equals to 39. Okay, so let's go to question number 3. Question number 3 requires some knowledge about Pythagoras Theorem, which we should be very familiar yourself with. So our robot goes to east for 28 minutes, 28 kilometers, and then goes south for 28. And then we will go on to 7 to the rest. So what we want to know is the distance between these 2 points, the starting point and the finishing point. Now, since Robert are actually walking in a straight line and only turns it only turns 90 degrees each time. So that's why this 2 are 90 degrees, and we can see that if we divide it into 2 parts, we can see that because this is of length 28, and hence this is also of length 28. But for our top one, because it is of length 28, but we need to minus this length as 7, so this is equals to 21. So we find out a right angle triangle in which its 2 sizes are 21 and 28. And by this, we can calculate the distance. So the distance square is equal to 12 square plus 28 square. It is equals to our, now 21 and 28 are both a multiplication of 7. So it will be equals to 7 square plus 7 squared multiplied to our 9 plus 4, 9 plus 16. But then this would be equals to 35 squared. So we know that because our distance square is equal to 35 squared, hence our distance is equal to 35. Okay, so this is the end of question number 3. Question number 4. Now, question number 4 is a question about mixture of ratio. It's a question about mixture of ratio. All you need to do is just combining all this ratio together, and the answer will be very obvious. So given that A to B is equal to 34, A and then B to C is 1/2, C to D is 4/C, D to E is 1/3, and then they all add up to 1014. What is the value of B? So by this, we'll combine it one by one. So A plus B is equal to 3 to 4, and B to C is 1 to 2. So we can see that in here, the common ratio is our B. So it will be represented by 2, 4, and 1 together. So by this, we can rewrite it as our A plus is our A plus our A to our B to our C, because we wanted the B can be divisible by 1, but also by 4. So we need to multiply the first equation by 4. So the whole thing will be equals to 12 plus 4 plus if you look into this 12 oh, excuse me, this is not 12 plus 4. This is 3 plus 4 because we want the 4 in B, but then later on this will be equals 4 plus 8. Why 8? It is equal because that our 1 to 2 for our B to C need to match up to the A to B, so they will need to have a constant B, and so we have to multiply our B to C by a greater ratio. So by this, we can now using this and the next equation to form a new equation. Again, this common method is to find out the common values for the common factor, which is of our C. So we know that in here for A, B, C is 3, 4, 8, and C to D is 4 to 3. So if we multiplied our C by 2, we can multiply by our D by 2. And hence this would be equal to something like this. So it would be equal to 3 to 4 to 8, because it used to be 4 to 3, but one of them is 8, so the other need to multiply by 2, which you will get is 8 to 6. So finally, for our last part, which is our D to E. By this, we can convert this D to D in here. And so we can rewrite this whole thing by A times B times C times D times E, which is equals to now, because the D in the last cases is 6 and the D in the D times E is 1, we need to multiply our last ratio by 6 in order to make it having a common ratio. So this would be equal to 3 times 4 times 8 times 6 times 18. Now, by computing this, we can now know a very important result, because we know that A to B to C to D to total. But what is a total? A total is the sum of all terms. So it will be a 3 times 4 times 3 plus 4 plus 8 plus 6 plus 18. So it will be equal to 26, 32, 34, 39. Okay, so in total there are 39 cases. And once we get this number, now remember that what we mean by having the total is 39, which means that our total can be by make use of the ratio constant. So we can rewrite it as 39 times K, which is equal to 1014. Okay, so it means our K is equal to 1014 divided by 30. divided by 39. So if we divide it by hand, you will see that the answer of it is equals to 26. So once we know that K is actually equals to 26, we can immediately use it to back to our original condition, because B is equals to 4 of it. It's equals to 4 pieces. It would be equals to 26 times 4. It will be equals to 108. Okay, so this is the end of question number 4. This is the end of question number 4. Now, question number 5. If A, B, C, D, and B, A, D, C is equal to 1, 2, 2, 6, 5, calculate the following value. Now, I would like to announce an errata for question number 5. So instead of calculating the difference, instead, please exchange it into the following thing. Please change to A plus B plus C plus D. Now this is an errata because the values within our expression is there is no unique answer for it. Okay, so now let's go back into this question. So every time we see a summation problem like this, all we want to ask is, what does that mean? What does all this title mean? So it will, because L is A, B, C, D. So we can rewrite it as 1000A plus 110B plus 10C plus D. Now the same thing goes for our BADC. Now this is what we called a digit of base 10, right? So again, this would be equal to 1000B plus our 100A plus our D, our 10D plus our C. But by this, we can now try to sum these two together. Now sum these two together. On our left-hand side, it will be equal to 12265. It will be equal to 12265. Now on our right-hand side, things become interesting. So the first term is equal to 1000A plus B. The second term is equal to 100A plus B. So our left-hand side, it can be written as 1100 times A plus B. So on our second question, it will be equals to 11 times our C plus B, C plus D. Okay, now once you do this, now here comes my question. Now notice that C plus D is never ever going to be exceed 20, right? So 11 times 20 can never ever be exceeding 1100. So it's impossible impossible for this in this expression a plus b and c plus d having a different values, because there's nothing that can make the carryover of c plus d be affecting the values of 1100. Now in here we know that our 12125 can be written as it can be written as our 11 times our 1100 plus our 11 times our 15. So the only way for this to happen is for our a plus b is equals to our 100, and for our c plus d is equals to a 50. So in other words, we know that AB must be equal to 11 and CD must be equal to 15. No other way is possible. So what is the value of A plus B plus C plus D? It will be equal to 11 plus 15, and hence it will equal to 26. Okay. So this is our question number 5. This is our question number 5. Okay, so our next question, according to questions shown below, what is the number within our bracket? 3, 8, 23, 68, 203, 608. Now again, this number is a tricky one. So I will show you the relationship first. If you try to multiply the numbers on our left, and then you by 3, and then you subtract it by 1, you get the numbers in your direct right hand side. So this is plus 3 minus 1, and then for 8 plus 3 is equals to 24, minus 1 is equals to 23. 2 is 68. 23 times 3 minus 1 is 68. 66 times 3 minus 1 is again 203. 203 times 6 times 3 minus 1 is equals to our 68. So by following this pattern, we know that the final number must be equals to 608 times 3 minus 1. So it would be equals to our 18 times 73. No, 18, and this is 18 times 23. Okay. So this is the question number 6. So is there any question for question 6? If no, then we will proceed to the next topic. Okay, question number 7. Find the value of x if these two equations are correct. Now again, it's very simple. All we need to do is just adding these two equations together and these two equations together. Now if we write it on side by side, it will be very easy to see. So if we add these two together, so for our minus 2y and plus 2y, they will cancel out. For our 3x plus x, then it will be go to 4x. And for our 5 and 7, it will be going to 12. So you can immediately see that since 4x is equal to 12, so x is equal to 3. All right. Now this is very simple, a very simple substitution. Now let's go to question number 8. How many integral solutions are there for our x? Now, whenever we see an inequality like this, all we need to do is just keep on replacing the difficult stuff. For example, in here, the most difficult stuff is divided by 3. So we multiply both sides by, we multiply all three sizes by 3. And the middle one will get canceled out to the divisible by 3. So what we get is the following. It will be equal to 30 more than 5x plus 4, which is more than our 37 plus times 3 is equal to 101. Oh, this is 5, okay? So again, we can subtract both sides by 4. So if we trace 6 is greater than 5x is more than or equals to 97. Oh yes, this is 111. Yeah, I'm sorry. This should be 107. Okay. Yes, very good. Thank you. So just by looking to this, we immediately can divide both sides by 5. Then we can get our answer. We can divide both sides by 5, and we can get our answer. Because now in this step, we want to get rid of the 4. And then later on, we're going to get rid of the 5. So if we get rid of the 5, we know that. So it will be 5 and 1/5. 5 and 1/5, and which is x is from 5 to 1/5 to our 21 to a 2/5. Okay, so or in other words, x can only be 6, 7, 8, 9 up until to our 21. So how many numbers are there? How many numbers are here? This is equals to 16 numbers. You can count directly, and hence our answer. How many integral solutions are there? 16. Okay, so our next question, find the sum of positive values if these will be equal to 6. Now, again, in our question number 9, this in which it involves a absolute values, all we need to do is to get rid of this absolute value first. All we want to do is to get rid of this absolute value first. Now, how can we get rid of absolute value? Well, we follow the definition. The definition of absolute value says that the number within this absolute value, if the number within this absolute value is greater than 0, then it is unchanged. But if the number is more than 0, then it will change to its negative. So that's why the absolute value always gave you a positive number, regardless of whether the inside is positive or negative or not. Or in other words, the absolute value just gave you the magnitude of the number. It does not give you the sign of the number. So by drawing the graph, we can divide all the number of x into 3 different sections. Now, okay, first of all, let me answer the question for Didi. Now, in question number 5, the question is D minus C plus B minus A. Now, the question is wrong. The question is wrong. So that's why I gave you an errata. The errata says that the question should be asking you A plus B plus C plus D. Okay, the second of all is for Anna, is in question number 8, why 21 is included if it is not a less than or equal to sign. Now look back into our solution. Please look back into our solution. Now in our solution, now let me go back into here. Our solution is this. Now because this is something that we usually will not do it again. We usually will not do it again, but in here, notice that this is not 21, but instead this is, what is it? This is 21 and 2/5. So this is a composite rational number. So it is less than, but it is less than 21 and 2/5, and hence even 21 is included. Okay. Okay, so let us go back to our questions here. Now, again, we would like to divide this into 3 sections. Now, why 3 sections is corresponding to the 2 criteria of our absolute value. One is that we need to consider the x for which it is greater, for which this one is going to be 0. The second of which is to consider whether this one would be equal to 0. So for our first line, it would be this line. This line is for the number which is of our -4. So because it is now for whatever number which is less than -4, then the red part will be negative number. So its real value will be -4x minus 4 instead of x plus 4. You need to put a negative sign in it. Now, another important number is our 6. Because whenever our number x is greater than 6, the whole equation will turn into 6 minus x, 6 minus x minus 6 instead of 6 minus x. So let me rephrase one more time. Whenever a number x is now let me jot down the range of it. So this is whenever x is less than 4. So for our red one, this is no longer x plus 4. In fact, it is -6, -4. Okay. But for all other regions, so for x is greater than 4 and is less than 6, and for our x is greater than 6. Now, of course, you need to consider the exact value when our x is exactly equals to -4 and exactly equals to 6. But because we do not have enough space, we are not going to write down the exact formulas for these 2 particular values. Okay. So for our red one, x plus 4, as long as x plus 4 is positive, which is when x is greater than -4, this would be just as normal. But if it is less than it, you need to get a negative sign of it. Now for our x, 6 minus x, if x is greater than 6, and it could become negative. So this is 6 minus x. But for all other situations, it will be equal to 6 minus x. Okay. So all we want to compute is that what is the difference between these two. So now let me write down in black what's the difference of it. So this will be equal to -2x minus 10. Okay. Again, for our red, the difference between red and our this is not -2x. So it should be -10, exactly -10, not because our -x and the negative or the minus negative x, they cancel out each other. So for the middle part, this is x plus 4 and 6 minus x, then x plus 4 minus 6 plus x, so this will be 2x minus 2. The middle part will be 2x minus 2, and the third part, because x plus 4 minus x plus 6, then it will be equal to 10. So we have 3 different sets of values. Whenever x is less than 4, less than negative 4, it will, this expression, the expression on our left, this one, will always be equal to negative 10. Okay, so for our expression, which is between our negative 4 and 6, it will be equal to 2x minus 4. And for x is greater than 6, it will always be equals to 10. But you see, there's no way for this expression to be equal to 6 for these two regions. So this two region is something that we do not need to consider. All we need to do to consider is for our middle region, for this region to be equal to 6. But what will it be when it's equal to 6? It means that our 2x is equals to 8, or in other words, x is equal to 4. So there's only one value for which this expression will be equals to 6. This is when our x is equals to 4. So our answer is exactly 4, because there's only one value of it. Okay. So now let's go on to question number 10. Factorizing this theorem. Now, whenever we see factorizing problem like this, especially this is a decoupling problem, we can rewrite this as the following. So it will be equals to x squared minus 2x plus 1 minus y squared minus 6y plus 9. Now you can check that both the left-hand side and right-hand side, they are the same. But what's the first part of this expression? The first part is exactly equal to x minus 1 squared. The second part is exactly equal to y minus 3 squared. Okay. So now by writing this, now we invoked a very important identity, which is the difference of square. The difference of squares state the following thing. If our a squared minus b squared can always be written as a minus b times a plus b. So we now can factorize it, right? In here, this is our a, this is our b. So we can invoke our identities to rewrite it as the following. So it will be x minus 1 minus y plus 3, or x minus 1 plus y minus 3. So the whole number will be equals to x minus y plus 2, or x plus y minus 4. So this is our answer. Hence we have factorized question number 10. All right. Now for question number 11. Now question number 11 is a very important. Now most of the time you will associate this type of question with a theory, which is called the Wheatus theorem. But actually, it has nothing to do with Wheatus. Wheatus theorem is something else. Now, let me state how can we compute this question. Now, in here we see that it's a squared plus b squared. So in some sense, we want our a to multiply to our a and b to multiply to our b. But we cannot get it from here. because it is A times B, right? So the only thing that we can get is from here, A plus B. But A plus B, these are all only a first order. This is not the second order. So how can we get it? Now we want to compute the square of this. Now the square of this is, of course, is equal to A squared plus B squared plus our 2AB. But look, right? This is equal to 81. This is equal to 81, but here, this is our green part. As long as we know what is the remaining of this, then we can find the solution. But this is something we know because we know AB is 13, right? We know AB is 13. So this one is exactly equals to our A squared plus B squared plus 26. So all we need to do is just subtract the whole thing by 26, and hence we will get our answer. So at the end of the day, what we get is the following. A squared plus B squared is equals to 55. Now, this is very, very useful. In fact, I would like to say that as long as you have a equation which is related to A and B, and A and B is so-called symmetric, in which we can we can exchange A by B and B by A, and it will not change the equation. This is called a symmetric equation. And every time you have a symmetric equation, you can always find its value, disregard the values of A and B by just knowing these two numbers. This is called the Newton's equation or Newton's polynomial. But I will defer the discussion of it until higher levels in which we will apply it extensively. Okay, so now let's go to question 12. Given that x is a real number, find the minimum value of this. Now again, whenever we find a minimum value, what we need to do is to try to complete square. Now it's almost always the case. These cases, complete the square. Now, what do you mean by completing square? Completing square is to rewrite a correct quadratic equation such that it can consist of a square and some constant. Rewrite the, now notice that it can only apply to a quadratic equation, nothing else. If it is a cubic, you cannot use this method. You rewrite the quadratic equation into a square and some constant. Okay, so now let's apply this in here. So now we have an equation in here. So let me rewrite it as x squared plus 10x plus 25 minus 75. Now, why we want to do this? Just like what we are doing in question number 10, because the first part is exactly equals to our x plus 5 squared minus 75. Okay. Now, here comes the important part. Notice that this part is always greater than or equal to 0. This part is always greater than or equal to 0. It will only equals to 0 as long as x is equals to -5. Or in other words, x plus 5 is equal to 0. Other than that, it will always be greater than 0. And hence, this will achieve its minimum only when x is equal to 5. So this equation will have a minimum exactly on -75, which is when our x is equals to -5. And then that will make it to be minimum because we are adding something which is positive to a negative number. So this number, we want this to be minimum. Or this now the whole expression will be minimum only if the pink part will be going to be minimum. But since it is square, its minimum will only be 0. Now sometimes I would like to add one more thing. Sometimes if the minimum is not 0, it cannot be achieved. This time it can be achieved because, as we know, x can be equal to -5. But you need to be very careful. Sometimes the square, the expression within the square cannot be 0. So at that time, you need to recalculate it. So to find out what is the minimum of the square. But then this is more of a question in senior secondary school. Okay, so here we have finished discussing the whole paper on the whole section on our arithmetic. Okay, let's go on to our next section. C minus b squared divided by 4a is the easier way. Yes. And no, but I mean, you complete square is usually more easy for you to do than applying the quadratic equation. Now the quadratic equation, most of the time you don't only use it when you have no other method. But complete square is not that difficult, right? Okay, so let's go to the next section, which is number theory. Okay, so first question is difficult. Now find the last digit of a if this is true. Now let me rewrite this. Now we know that a is the sum of all this part. Let me rewrite this part in the following form. So what's 5? 5 is actually equals to 2 to the power 1 and then plus our 3, right? So this is our 5. So this is our first number. And for our second number, 7, it is actually 2 to the power 2. Again, it is plus 3. It will be equals to our 7. Now the same thing goes on and on a bit. Now the number now will become bigger and bigger, so it will be harder and harder for us to evaluate the exact value of it. Okay, so now I will not go on to list out all the possible way of writing this, other than the last two is this two. So it will be 2 to the 19 plus 3 and 2 to the 20 plus 3. Okay, so now the sum of all this number will be our A, right? 5 plus 7 plus 11 and so on and so forth. The sum of all the green and all the black will be of A. Now, first of all, I would like to ask, how many numbers are here? How many terms are here for our sum A? There are, because we start from 2 to the power 1 and we end up and we go on from 2 to the power 2, 3 up until 20. So there are exactly 20 terms, right? There are exactly 20 terms. So if we want to sum it up, there's another way to do this, which is we sum it up separately, right? So for our numbers on our right, because we know that there are exactly 20 terms, so this sum will be equals to 3 times 20, hence it will be equals to 60. Right? This will the terms in our right will be equal to 60. But now here comes another question. What is the sum of this part? What's the sum of this part? But this part is simply a arithmetic series. No, it is a geometric series. This part is a geometric series. Because all the terms are just, they have the same common ratio, which is 2. Or they have a so-called a common common ratio, which is equals to 2. The next term is always 2 times the previous term, okay? So for a geometric series of this, you can apply this sum, the equation of sum for this series. The sum will be equals to the last term times the common ratio. In this case, it will be common ratio CR minus the first term, and then we divide it by our common ratio minus 1. So this is the equation for the sum of a geometric series. So let us use this equation. Now for our last term, it will be 2 to the power 20. So this term will be equals to, now let me list it one by one. To the first term, here our last term, it is equal to 2 to the power 20. Our common difference is 2. Our first term is also 2. Our common ratio is also 2. So if we multiply them together, we know that our sum will be the following number. It will be equals to our 2 to the power of 21 minus 2. Or in other words, you can write it as 2 times our 2 to the power 20 minus 1. Okay, so all we need to do is to just find out the sum. Now usually this is very hard to find out, but we know that 2 to the power 10 is exactly equal to 1024. Right? So 2 to the power 20 is simply 1024 to the square. Now notice that in here, do we need to find the exact value of this number? No. Why? Because all we need to do is to find out the last digit. So what is the last digit of it? The last digit of it is equivalent to 4 to the power 2, which is equivalent to 6. Because it will be equivalent to 16, right? So all we know is that this term is equivalent to 6. So it will be equivalent to 6. So it will be equivalent to 6 minus 1, which is 5 times 2, and hence the whole term will be equivalent to 0. So the sum, the last digit of the first sum is equivalent to 0. But the last digit of the second sum, our black number, is also 0. So what is the last digit of this number? It will be 0, right? So the last digit is exactly a big 0. So this is how we finish question 13. Okay. So now let's go to question 14. Find the remainder of it 43 to the power 14 when it's divided by 8. When it's divided by 8. Now in here, we need to apply the logic of modular arithmetic. Now in modular arithmetic, we always say that if A is equivalent to B mod M, what does that mean? It means that A and B have a common. It means the following thing. A, the remainder of A divided by M is the same as the remainder of B divided by M. These two remainder, they are the same. If these two remainder, they are the same, then these two are called equivalent. or in other words, we will write it as the following: A is equivalent to B mod M. Okay, so this is the notation that we use. Now, one very important thing about modular arithmetic is that whenever these two numbers are equivalent, you can always replace one number by another when you are calculating the remainder of it. So because we want to calculate the remainder of 43 to the power of 14 when it's divided by 8. Now also, let us realize that 43 is equivalent to 3 when it's divided by 8. So according to our rules, we know that 43 to the power of 14 is equivalent to 3 to the power of 14 more when it's divided by 8. They have the same divisor. They have the same remainder. But now let's compute even further. Why? Because what is 3 to the power 14? 3 to the power 14 is exactly equals to 9 to the power of 7. Okay, oh, so far so good. But now let me apply another theorem, another equation, because 9 is equivalent to 1 when it's divided by 8. So our 9 to the power 7 is equivalent to 1 to the power 7, and hence it will be equal to 1 mod 8. So we know that at the very beginning we have our questions, but since it is equivalent, 9 to the power 7 when divided by 8, and 9 divided by 7 is equivalent to 1 when divided by 8. So these two must be equivalent. Hence, the remainder of our number so large, which is 48 to the power of 14 when divided by 8, has a remainder of 1. Okay, so this is the power of our modular arithmetic. Whenever they have the same remainder, you can always replace one by the other when computing this remainder. Okay, so this is question number 14. Okay, let's look at question number 15. If x to the power x plus 4 is a factor of our polynomial, find the value of c. Now, in this case, we will need to invoke another very powerful theorem, which is our factor theorem. What is our factor theorem? Now, although it is called factor theorem, but it is really not the strongest part of the theorem. It is a very simple part of it. Now, in here, what do you mean by x plus 4 is a factor of this? What do you mean by is a factor of this? It means that it can be written as x plus 4 times some other thing, right? Some other thing, something that we don't know or we don't care, right? So, but if we don't know the red part, how can we find out the C? The trick is to know that if our green part, this part, if it can be written as this, so it means that if our x plus 4 is equal to 0, so this part equals to 0, and because the whole thing will be 0 multiplied to something, which implies that our blue part must also equal to 0. Because our blue part is a green part multiplied to something. So for a particular x, it would be equals to the value of green times the value of red. Although the value of red is something that we do not know, we know that because x plus 4 is a factor, so if our numbers, our values of blue must be a multiple of the values of green. But the value of green can be equal to 0. And it will when x is equal to -4. So this would be equal to 0. But what does that mean? It simply means that when x is equal to -4, the whole thing will go to 0. So let's now how could compute the value of x equals -4 for our blue equations? All we need to do is just substitute it, right? So we will be equal to 154 times -4 squared plus our, oh no, this is minus our 2121 times 4 and then plus c, and this will be equal to 0. Okay. Yes. Now, some of you may be able to find out what exactly is this red part. Now, if you know the red part, and then you can find out the multiplication of these two constants will get you a C, but it's not required because we can use the factor theorem to find out this. And the factor theorem will told you that in here, the first term it will be equal to 154 times 16. 154 times 16, which is equivalent, which is equal to our 2464. No. 154 times 16, which is equals to 2464. And then the next term will be -8184, and then plus c is equal to 0. So after rearrangement, we know that c must be equals to 5620. Okay, so our answer is 5620. Or if you would like to find it out by solving the factor, you can try to divide our whole equation by x plus 4, and then you find out the red part of the equation, and then it will be okay. All right, so this is the question of question 15. So now let us go to question 16. Now question 16 is something very close to our, very close to our question 11. So please compare these two questions if you would like to have a deeper insight of these two questions. So this is for our question 11. Okay. So again, we have something which is of a first order, and what we want is something which is of the second order. So again, we apply our tricks, which is we multiplied this number, we squared it. We just simply squared them. So what after we square them, what do we get? We get x squared plus 1 over x squared. Now, so far so good. This is exactly the orange part of it. But what's the next term? The next term will be 2 times our first term, x, times our second term, which is 1 over x, but they cancel out, right? So it will be equal to plus 2. And by this, we also know that this is exactly equal to 64, the x squared, the 8 squared. So we know that this part, our orange number plus 2 is equal to 64, hence our orange number must be equal to 64 minus 2, and hence it is equal to 62. And this is the answer, right? This is just the same treatment as in question number 11. As long as you know how to manipulate this equation, and you are done. It is just like, now it was just like that. Now we can rewrite this equation in this format, and you will see. So it will be, can be a plus b is equal to 8, and ab is equal to 1. And now what we want to ask is ask a squared plus b squared. What is the answer? these two are equivalent. And you can use the method that you use it in solving question 11 to solve question 16. It's just that it's not that trivial to see that the question 16 is just another cases for our question 11. Okay, so let's go to our question 17. Find the sum of all positive factors of this. Now, whenever we want to calculate the number of positive factor or the sum of positive factor, the first thing that we want to do is to do a prime factorization. In here, for our 402, this is exactly equals to our 2, and then it would be 2 times 3 times 67. Now 67, now 2, 3, and 67, they are all prime. Now after which then it's almost done. Now there are two major methods of doing this. The one is to you list out all the positive factor, because there's not much positive factor, there's only 8 of them. And then you add them all up and you get the answer. The other things to do this is to use the formula. The formula says that the sum of the positive factor says the following thing. The sum would be equals to, now you have this different part. We try to sum it for each of this part. For example, the 2, you try to sum it from a 1 to 2 up until its highest order. But since the highest order in here is just 2, so it will be sum 1 plus 2. The same thing goes for all other prime factors. Because there's a 3 here. So it starts from no 3 to one of them. And finally, the last part is our 67. So in here, it would be equals to our 1 plus 67. So our answer in here will be equals to our 2 times 3, 3 times 4 times 68. And hence it would be equals to 816. So 816 is our answer for question 17. Now let's go to our question 18. Question 18. If k to the power of 7 is equals to this, find the value of k. Now this is the power of estimation. This is the whole thing is asking you about estimation. Now, whenever you ask an estimation, we want to find the range of possible k. We find the range of k, and then we make this range smaller and smaller until we know the exact value of k. Okay, so at the very beginning, we will find a rough estimation of k. We find the range of k, and then we want to make it smaller and smaller. So now, given this number, do you know what numbers which is of a power of 7, which will be bounding this 19 million number? Now I do know two numbers that bound them. The first number is 10 to the power 7. Now 10 to the power 7 is simple. It's just 10 and 1 and 10 0. Now, of course, this number will be smaller than our k to the power 7. But what does it tell you? It tells you that k to the power 7 is actually, k must be greater than our 10. K must be greater than our 10. If not, then k to the power 7 will not be greater than 10 to the power 7. Okay, But there's another number which we can bound it. Another number which we can bound it. The other number, which is 20 to the power 7. 20 to the power 7, what is this? It is equal to 2, because 2 to the power 7 is 1 to 8. So it will be 1 to 8, multiply this whole thing. So it will be equals to 1 to 8, 1, and then to 8, 0, and then 0, 0, 0, and then 0, 0, 0. So of course, k to the power 7 is again smaller than this. So which means that by this two estimation, we know that k must be some number between our 10 and our 20. Okay. So this is not only our k is a 2-digit number, and its most significant digit is a 1. Okay. We know that the most significant digit is a 1. So here comes my next question. What is this number? What is its unit digit? Now here, we are no longer using our estimation. Now we want to find out the precise value of it. But how can we find it? We find it by comparing its last digit. You see, here we have a last digit which is equal to 1. So let us find what last digit would that be if it raised to the power of 7 will give us a last digit of 1. Now this is not much number that have this property. Now again, if the last digit is 0, if raised to the power 7, it does not give you a 1, it gave you a 0. 1 to the power 7, of course, it will give you a 1, which is good. How about 2 to the power 7? Again, 2 to the power 7 will not give you a last digit as 1. In fact, it will give you, because we know that the last digit always repeat in the cycle of 4. It will only give you a last digit of 8. So again, going through the same thing, so we know that it will give you a last, for 3, it will give you a last digit of 7. For 4, it will give you a last digit of 4. For 5, because no matter how many power you raise for 5, it will always going to be 5. The same goes for 6. And for 7, the 7 to the power of 7, it will be equal, the last digit is 3. And 8 to the power 7, the last digit is the same as 8 to the power 3. And then that number will just be equal to 2. And for 9 to the power of 7, the last digit will be 9 to the power, is equivalent to 9 to the power 3, but it is also equal to 9. So for all this number, for all of these numbers, there's only one number, only one last digit that satisfies our requirement. What is that? This will be this one, right? So we know that if k is true, its last digit must be equals to 1. So we know that what is the value of k? K must be equals to 11 if this is going to be true. But of course, since this is a question, this must be true. Okay. So this is the last question of our number theory. Now this is a very interesting trick, and I hope that you can know how to do this estimation question. First of all, we find the range to bound it. We find the most significant digit of it, and then later on, when we find it small enough, then we will use the last digit to find the last digit of our target number k. All right. So let's go to our next question, question 19. The radius of our sector is 10 and its area is 35. Find the perimeter of this sector. Now, let me draw this sector out. So we have the number which is like this. Let me draw them out. So what is the area? What is the area of this sector? Now this area of the sector is closely related to this angle. Now let's call this angle A. Let's call this angle A. So how can we find the area? How can we find the area? This area, 45, is exactly equals to, our pi times the radius squared times the angle divided by 360. Okay, so this is equal to 35. So by this, we now can immediately calculate that what is, now let me rewrite this. Now maybe A is not a suitable number. Let's call it W. W will be better. Okay. So now if we calculate, we multiply them together, we know that our pi times W, what is pi times W in this case? It will be equal to 335 times 360 divided by 100. So it will be equal to 126. So this is the value of pi times RW. So now, after knowing this fact, let us calculate the parameter of this factor. Now the parameter of this factor is separated into two pieces, mainly two pieces. Maybe some of you will say that it's 3 pieces. It is the 2 pieces of the straight line, in which they will be in total is 20, and the later part is the art of this. So this part, the art of it. But how can we calculate the art? Again, just like area, if we calculate the whole circumference of the circle, and then we multiply by our ratio for our angle. Okay, we compute the ratio of our angle. So maybe we don't use our x here, not so that it will not be confusing. Okay, but then in here, we already know that pi times W is 126. So the whole thing will now become 20 times 20 times 126 divided by 360. So if we're going to calculate them, so this would be equals to 7. And hence our parameter is equal to 27 for our question 19. All right, the parameter will be equal to 27. Now let's go on to talk about question 20. Now we have just finished question 19, and now we call about question 20. Now question 20 is a application to calculate the slope calculation. Is the slope by 2-point form. Now remember that if we have 2 points in here, in a Cartesian coordinate, if we have 2 points, and we was given the coordinate of these 2 points, we can now use this 2 coordinates. Now let's call this 2 point having coordinates x2, y2, and then the bottom one is equal to x1, y1, and we can use it to calculate our slope. What is our slope here? In this case, the slope would be equals to y2 minus y1 divided by our x2 minus x1. Okay, so this is our 2-point form of the slope. But then in here, now if we draw our diagrams, in here. If we draw our diagrams, so we will see something like this. there are 2 points here. One is in here, which is our 4, 1 to 1. And the other point is in here, which is exactly our x-intercept. Now, the x-intercept is something that we do not know. Let's call it just towards x. But because it is an x-intercept, it lies on our x-axis, and its y-coordinate must be equal to 0. So now we want to calculate the slope of this curve. And we know that the slope is equals to 11. So by this, we now make use of the 2-point form. We know that the slope is equals to 11, but it's also equals to 1 to 1 minus 0 divided by our 4 minus x. Okay. So after rearrangement, we will know that our 4 minus x is equals to 11, or in other words, we know that our x must be equals to -7. So -7 is the x-intercept of y, of L. Okay. So let us continue to our question 21. Now, question 21 is, now in here we will state a very, very useful formula, Heron's formula. Heron's formula to calculate the area of triangle using only the 3 sizes. Okay. Now, Heron's formula is a formula in which if you only need to know the 3 sizes of the triangles, and by using the formula, you can calculate the exact area of that triangle. Because if you know the 3 sizes, you almost fix the triangle, right? Now, before we use the formula, let's define something called S, which is called the half parameter. The half parameter is just like the name. It was the parameter of our triangle divided by 2. So in this case, it will be 20 plus 21 plus 29 divided by 2. And by this, it would be equals to 35. So once we have our half parameter, we now state the theory. The theory says that the area of this triangle is exactly equals to root of s times s minus the first sign, and then s minus the second sign, and the s minus the third sign. Okay. Now remember that the root of it is extended to our last term. So we calculate s times s minus 20 times s minus 21 times s minus 29, and then we take the square root of it. It would be our answer. Now let us compute it in this particular cases. Our s would be equal. Our s is exactly equals to our 35. And then our s minus 20 is equals to 15, s minus 21 is 14, s minus 29 is 6. So our answer will be equals to 35 times 15 times 14 times 6. But this, if we compute how many 7 are there are 2 7 within our square root, 2 2 within the square root, 2 3 within the square root, and 2 5 within the square root. And hence, this answer will be exactly equal to 2 times 3 times 5 times 7. And we can calculate this area if it exactly equals to 210. So this is our Heron's formula. And by this, we can calculate the answer, which is 210. Now this formula is extremely useful because you now no longer need to calculate the angles of all triangles. You now no longer need to calculate the height of the triangle, which is very tedious, and it involves a lot of Pythagoras Theorem, or sometimes even worse, something that we call a cosine law, which is very, 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 very difficult to do. Okay, so let's look at our question 22. For 3 points in the coordinate plane, find the area of a triangle formed by using this 3 points in as a vertex. Now, whenever we see this kind of question, now there are actually a formula of it. There are a formulas for this kind of computing the areas of 3 points. But I will not give you the formulas here. And you may refer back to the notes that if you are studying general mathematics, you may referring back to the notes for the formulas. But why we don't use the formula is not that I don't want to tell you how to do this, but it is more likely that the formula is not that useful indeed. So instead of using formula, let us compute directly. Now, first, whenever we see this kind of question, the first thing we would like to do is to plot the corresponding positions of all these points. We plot all these points on our sketch paper first. Now we have our point, which is our point A, which is 3, -1. Now you can listen to me. And or maybe you can refer back to the paper, because I need some space for drawing the diagram, so I will not show you the paper now. So this is a point A, 3, -1. How about point B? Point B is 2, 5. So our point B is somewhere in here. Point B, 2, 5. And finally, we have our point C. Our point C is -5, 3. So our point C is somewhere like here. C, -5, 3. So how can we calculate the area when we join these 3 points together? How do you calculate the area of this triangle? Now, this is actually very simple. Now, instead of calculating this triangle directly, we calculate the rectangle that encompasses the whole triangle. We calculate this area, and notice that this rectangle, if we trim out this part, if we get rid of this part, this red right angle triangle, if we get rid of this part, again, and another right angle triangle, but this time it's blue. And if we get rid of this part, which is a purple right angle triangle, if we get rid of all these 3 parts, what remains is exactly the area of our triangle. So let us calculate it one by one. So the area of the rectangle. Now, the area of a rectangle is simply its length plus its width. So now let us mark down the value of length and width for each number. So now for our rectangle, its length, it goes from -5 to 3, so this length is 8. Okay, for its width, it is from -1 to 5, so the width is equal to 6. But then we also know that for the x coordinate of A to B, it will be equal to 1 because it is from 2 to 3. And then by this, from -5 to 2, it will be 7. From 3 to 5, it will be equal to 2. And finally, from -1 to 3, it will be equal to 4. So by this, we can clearly map out that the area of our rectangle is equals to 8 times 6, is equal to 48. Okay, So how about the area of our red triangle? Our area of a red triangle, the red triangle have a base of 7, have a height of 2. So it will be equal to 7 times 2 divided by 2, and hence its area is equal to 7. Okay, so how about the blue one? How about the blue one? For our blue triangle, it has a base of 6. It has a height of 1, so it will have an area of 3. Okay, finally, how about the purple one? For our purple triangle, it has a base of 6. It has a height of 4, so it will have an area of 12. So that's why we know that after combining all this together, we know that the area of our ABC, which will then be equals to 48 minus 7 minus 3 minus 12. It will be exactly equals to 48 minus 22, and hence it will be equal to 26. And 26 is our answer. Now, again, this is not that difficult. Even if you do not remember the formulas for which you can use it to calculate all the points. Now, this method is particularly useful if the points that if the shape that you want to find is not triangle, but in fact it is a quadrilateral or even a pentagon. Now, in those cases, it is very now we still have a formula for it, but it is very, very easy for you to misuse the formula and to get the wrong answer. Hence, as always, I would recommend you draw the diagram and analyze it using basic geometrical properties. Okay, so let's go back to our questions. Question 23. It is 6 times 4 or 6 times 8. It is 6 times 8 because the rectangle, this is a rectangle, right? It is a rectangle. It is not a, let's see. Are you asking about this one? Oh, yes. I see. Yes, I'm sorry. I'm sorry. It should be 8 times 4. So in fact, this should be 16. Okay, I'm sorry. So this would be 26 and 16, and hence it would be 22. So the answer is 22. Yes, you're correct. Yes, you're correct. So thank you for pointing it out. Talk about this. Your talk about this. I think it's called this way. I do not know the exact name for the method, but it involves using the matrix of the coordinates of each of these points, which is very, very tedious. I don't like that. I don't like that at all. Okay. So is that a question for question 23? If no, then let's go back to our question. No, is that a question for question 22? Now let's go back to 23. Now for question 23, we need to find out the midpoint of it. What is the midpoint of this? The midpoint, there are a formula for it. If M is a midpoint of it, so its x coordinate must be equal to the midpoint of 5 and 17, negative 17. So we know that, so this is the midpoint of it. So we know that this must be equal to negative 6. Okay. But also because our M is a midpoint, now X must be the midpoint of our Y plus 2 divided by 2. No, this is negative 8. Negative 8. And by this, you can calculate that our Y is equals to our negative 18. So what's the value of X plus Y? It has to be, because our X is equals to negative 6. Y is negative 18, and hence it will be equal to negative 24. Okay, so the answer is equals to negative 24. Okay, so our final question for this part is our question 24. Now, if we draw our diagram out, now again, it's not necessary, it's just easier to understand. So we know that these are the interior angle. These are the interior angle, but the sum of that, what's the sum of all this angle? The sum, we know that the sum of all the interiors of a pentagon, sum of the interior or the interior angle is exactly equals to our n minus 2 times our 180. But in this case, the n is the number of sides of, so it will be equals to 3 times our 180, and hence it will be equals to 340. Okay, 540. Yes, right? Now we know that the sum of it equals to 540, but we know that the ratio is 5 to 4 to 3 to 2 to 1. So it means that one angle takes 5 parts, the other takes 4, one takes 3, and 2, and 1. So what about in total? How many parts are there in total? So in total, it will be, the total will be equals to our 5 plus 4 plus 3 plus 2 plus 1 is equals to 15. So if we divide this 540 into 15 parts, we know that the angles will be of 1 part, 2 part, 3 part, 4 part, and 5 parts. Now, here comes my question. What is our greatest exterior angle? What is our greatest exterior angle? The greatest exterior angle means is our greatest angle, our greatest exterior angle is the same, because we know that our greatest exterior angle is equals, when added to a interior angle, they always equals to 180 degrees. So our greatest exterior angle is equals to 18 minus our smallest interior angle. But in this case, our smallest interior angle happens to only be a part of 340. So it will be equals to 36. So we know that our greatest exterior angle will be equals to 144. Our greatest exterior angle is equal to 144. Okay. So 144 is our answer. Okay, let's go on to talk about the next question, which is our final part. Now, 29 cards are marked from 4 to 32, and 2 cards are drawn random. Find the probability that the sum of 2 cards are even. Now, first of all, when there's 2 numbers that sum up into an even number, there are only 2 possible ways. One is that it was an odd number plus another odd number. And 2, it would be an even number plus another even number. So let us consider these 2 conditions separately. So the first thing, in our first condition, we want to calculate the possibility of drawing 2 odd number cards. But by the way, how many odd number cards are there? How many odd number cards are there? Because we have 29 cards from 4 to 32, it is very easy to see that this 35 consists of 14 odd and 15 even. Okay, so if we want to draw them as a odd number card, so the number of ways to draw this odd number of cards, it will be equals to 14 times 15 divided by the total number of cards, 29 times 28. So in this case, in this sense, after we cancel them out, it will equal to 13 over 58. Exterior angle, no. Exterior angle is the no. Exterior angle or no. Now, given a size, what now? This is our interior angle. what is the exterior angle? The exterior angle is the extension of the side. So this one, the red one, now it is very easy to mistake. It's very easy to mistake that the exterior angle is this blue angle, but no, the exterior angle is the red angle, this one. The exterior angle sum up to the interior angle always going to be 180. Okay. Now I know this is very confusing, right? Why call it exterior angle? Okay. So now for this two probability, the probability of the first thing to happen is equals to our 13/58. The probability of the second half, that is, we draw two even cards, it will be equals to 29 times 28, and hence it would be equal to 15/38. So this is for our second condition. So the sum of it, so in total, it will be equals to our 28 divided by 58, and hence this is the probability will be equal to 14/29. Okay. Now again, how can you calculate the minute and the hour handle and minute handle overlap between 3 p.m. and 4 p.m.? Now for our question 26, at the very beginning, at exactly 3 p.m., our hourly hand is leading 90 degrees ahead of our minute hand. But in order for them to overlap, it means that it must trace the time minute hand overtake our hourly hand. What's time? Because we know that hourly hand, no, the minute hand, the minute hand overtake the hour hand, because we know that our minute hand is always faster than our hourly hand. A minute hand is faster than our hourly hand by how much? By 3.5 degrees per minute. Okay. 5.5 degrees per minute. So based on this information, and we know that our hourly hand is actually leaded ahead by 90 degrees. So the time it takes is exactly equals to 90 divided by 5.5, or in other words, it will be equal to 180 divided by 11, or 6, or it is equal to 16 and 4/11 minutes. So the time it takes is with 3 and 16 and 8, 11, 4/11 p.m. Okay. So for our question 27, it is known that our ABCD is find the number of solutions set for this. Now the number of solutions set is exactly the way we divide, is exactly the way we divide this 8 interval. We choose the 3 separation for the 8 interval between the 9 numbers. So it will be equal to 8/8C3. And hence it will be equals 8 times 7 times 6 divided by 3 times 2 times 1. And hence it will be equal to 56. Okay. Now for our question 28, we can rewrite this equation is something like this. It will be equals to 2xy minus 3x plus 6y. And then now let us add one more numbers, which will minus 9, and hence it will be equal to 20. But then the equation on our left-hand side can be rewritten as the following. can be rewritten as our 2y minus 3 times our x plus 3. So now all we need to do is to analyze how many ways can you rewrite 20 into these two parts. So because now in here, we will see that our x plus 3 is one of the factor of our 20, but it must be greater than or equal to 4. So our x plus 3 can be equal to 4, 5, 10, and 20. There's only 4 ways of doing this. So there are 4 solutions. No, there's only 2. Okay, yes. Now for this, then we know that the 2y minus 3, and it will be equals to 5, and then 4, and then it will be 2, and then equal to 1. But notice that in here, since our 2y minus 3 cannot be equals to 4 and 2. Why? Because this one is a odd number, right? So it cannot be equals to 4 and 2, and hence our original number cannot be equal to 5 and 10, and hence there are only 2 different ways of doing this. Is that when our x is equal to 1 and when our x is equals to 17. Okay, so I'm sorry because of the time allowance, then there are now I will entrust you to finish the last 2 questions. So this is the end of today's lesson. Thank you very much for your attendance, and I will see. I wish you have a wonderful day, and goodbye.